most common type of revamp and repower projects that we are witnessing today are around the power conversion technology, the inverters. So we are seeing both string inverters and centralized inverters that are becoming less reliable. We're running out of spares. Perhaps the manufacturer has gone out of business, and owners and operators are really struggling to meet performance targets. We must remember that the inverters on a solar farm are the real workhorses. They are on and off every day, and there's mechanical devices in there that wear out. The most common type of inverter change out as part of a repowering exercise is a like for a centralized inverter. This is where you're taking a certain power rating of inverter that's in a place covering an area of a solar farm, and you're exchanging it almost like for like. So you're making one redundant and bringing a new and improved inverter online in its place. We are aware of other configurations which are going on as part of these types of enhancement projects, where we're replacing centralized inverters for centralized string configurations. So this is where you bring 20 or 30 string inverters all into one localized area, possibly in a container or a building, and take advantage of the existing AC and DC cable routing around the site. And of course, what this brings a client is much more reliability. If one inverter goes down, then it can be exchanged very quickly. If one inverter goes down, there's only a small area of the site which is not producing, as opposed to a centralized inverter is much larger areas of the site which will be without production. This type of project requires serious engineering. It's not as simple as plug and play, and we're dealing with high voltage cabling and terminations. So there's permits to work in place. There are senior authorized people that have to be involved in these types of projects from the start all the way through to commissioning. One of the main problems with operating solar farms, particularly in the UK, is module degradation and damage, and also the DC system itself in terms of insulation resistance problems, failing connectors, and problems with the DC cable. There are multiple projects out there already which are exchanging either 100% or a large proportion of solar panels on site, old for new, and likewise sites are being completely restrung on the DC side, replacing all of the DC connectors, the MC4 connectors, and all of the DC cable itself. This can be combined with changes to the orientation and also the string configuration on site. There are a lot of sites in the UK that have modules in portrait orientation, and this causes problems with row-on-row shading, and the site will see significant losses because of this. This decision was made to cram as much DC power on the site as possible, but it's not doing any favours from a yield perspective. Also, the modules are strung in some cases in a U or a C configuration, which means that when you have row-on-row shading, half of each string on the site is actually affected by these losses. So we are seeing projects where portrait modules with U and C configuration stringing are now being reconfigured into landscape orientation with horizontal stringing, and this brings with it significant yield improvements. We then move on to optimization technologies. These are retrofittable pieces of equipment that you can design into your operational solar farm to make yield improvements. The main types of technology in this area are PID healing technology and MPP tracking technology, which both increase yields. 2 degrees Kelvin have been through a 60 megawatt portfolio in the last 2 months in the middle of winter, and we've already seen 2 to 3% site-wide performance uplifts, which is unbelievable. The other technology worth mentioning is anti-reflective coatings. Now, most modules manufactured after 2015 have these anti-reflective coatings already built in to the outer layer of the glass on the solar panel itself. But there are a particular vintage of solar panels which date before this, which don't have this anti-reflective coating. The developers of this technology are now looking to apply this retrospective coating onto multi-megawatt sites, but it's in the infancy of the technology trials, so we really don't know where it's going to go. And of course, it's quite a narrow band of older modules that we're looking to apply this method to. And of course, we've still got the question about warranties. What does it do to the module warranties? So the jury is still out on the retrospective anti-reflective coating applications. It's quite an exciting time within the utility scale power sector with all of these technologies coming through, and I'm sure there'll be plenty more in the years to come.